All right, so today we'll take a look at environments and scoping rules, okay? All right, so first we'll start off with binding and scoping, all right? So there's a few things we already know, right? When you create stuff, you're working in R, and you've got your workspace, your global environment. That's pretty much where you're creating your names and your variables and all of that, okay? The body of a function is when you execute a function, it creates its own local environment or its own execution environment, and the values inside inside that environment are only accessible to the function itself, right? Those objects created inside a function do not appear out in the global environment, okay? And anything inside the local environment takes precedence over the global environment. So if you've got objects with the same name, okay, the local environment masks the object in the local environment masks the object in the global environment, okay? So, we're accustomed to doing stuff like this in real life, right? So, for example, at home, maybe you have a relative named John, okay? Like you have a cousin named John or something. And then at school, maybe you have a friend named John, okay? And so when you're talking to your other people at school, all right, and you talk about John, you know that you're talking about the local person, the John that exists at school, right? Whereas if you're no longer in the school context and you go back home or whatever and you're talking about John, you know you're talking about the John that's your cousin in your family, right? And so, our brain works this way in terms of being able to keep track of different variables or different things that have the same name, okay? And similarly, R has rules that define how it should find values associated with different names, okay? So we just kind of want to formalize this, all right? So, the way it works is that we can create some object, okay? The values 1, 2, and 3, and when we do this assignment operator, okay, what it's doing is that the assignment operator binds the name x to this vector 1, 2, 3, okay? It's binding it, and so what it does, this command actually is doing two separate things. It creates an object 1, 2, 3 that exists somewhere in memory in the computer, okay? So the way your computer does any kind of calculations is that this value has to exist somewhere in its memory, okay? And then it calls for that, okay? And so it creates this object, and then R then binds the name x to that object, okay? So we can say x is a variable or a reference or a pointer to that vector, okay? X points to the memory location in the computer that contains the value 1, 2, 3. All right. I don't know if you guys taken a CS course and you remember pointers from there. This is not a CS course. Okay. We're not going to get into a whole bunch of theory here, but just very basic. This is just a concept that here's a name and it's pointing to this thing in memory. There's an address in memory and it's pointing to, and that address in memory has the values 1, 2, 3 in it. Okay. So here, just to kind of illustrate this, and I don't want to dwell too much on it. We have that first command. We create the object 1, 2, 3. We bind the name x. X points to that location in memory. Here we bind y to x, which actually says here's another name y points to the exact same object 1, 2, 3 in memory. So we've created this object 1, 2, 3 in memory. X points to it. Y points to the same thing. Okay. And then that third line z 1, 2, 3. We're creating a separate object with the values 1, 2, 3. It just happens to have the same values. And this name z points over here, okay? There's more, okay? I don't want to get into it, but technically R does stuff different from a lot of other languages. It does what's called copy on modify, and R objects are immutable. So this object that has 1, 2, 3, if we wanted to change the last value to the number 4 or something, okay, by doing like y single bracket 3 is arrow 4, then R will actually create a copy of this, and so X still points to the original 1, 2, 3, and then R creates a new object, a copy, with 1, 2, and 4 in it, and Y points to that, okay? And there's also things that kind of are optimized for speed, where it modifies things in place and all of that. We don't need to get into it, okay? If you're interested in kind of the CS aspects of the R language, you can read Hadley Wickham's book, Advanced R, which I've linked to in the syllabus. And you can also just go on Google, search Advanced R, and he pretty much has the text of his, the newest version, the second edition, just posted on his website, and you can just read through it. It's a very good read if you're interested in these aspects, okay? And if you're not, then, you don't have to read it, right? Only read stuff that you're interested in, or I guess you're required to, but I'm not requiring you to it. Okay. All right. So assignment is the act of binding a name to a value, right? And then scoping is the act of finding the value associated with a name. The scope of a variable is the region of code where the variable is defined. All right. So scoping rules are intuitive. So here we bind the name y to the value 1. And then we create a function g, which is a function of x. Okay, so we do g of x. And inside x, we bind y to 2, and we ask, and we return the value x plus y. Okay, so if I call g of 3, what is it going to return? So when g executes, 3, the value, the name x, argument x takes on the value 3, it's going to return x plus y. So what is it going to do? It's going to take 3, and then y has the value 2. It's going to return 5. Okay. And I think I forgot to put it, but yes, you are correct. G will return 5. Okay. The scoping comes into play when R can't find the variable inside its function, right? So here, it's the same thing, except we're missing this y is 2 button, right? Or y2 is line. So here we call f of 3, and inside here x will take on the value 3 because that's how we called it. X is 3 in our call, and it returns x plus y. Okay, but y is not given inside the function, so what R does is it applies the scoping rule, which says there's no y inside here, and so I climb and search the higher scope, and it finds the value 1, and it's going to return 4. Okay. So this is what we get back. F of 3 is 4. Okay. And that's like the basic rules. Okay. We already saw this where y is defined inside of g. Okay, and so this y masks the y that's in the global environment. Okay, and so when we call this, g of 3 returns 5. Okay, so we would say the name y here masks this name out here. Okay, that's all right. Yeah. Okay, I think I've talked about this already, but so when you run a function, or if there's a scope, variables inside a scope only exist inside that scope, and only for the duration of that scope. So when the function is done running, any variables created inside there are gone, because at the end of the function, that scope is destroyed. Okay. If variables exist outside the scope with the same name, those are separate, do not interact with the variables inside, okay, and they are not overwritten. Okay, every function has its kind of own separate environment, and that only communicates to the outside world via the arguments coming in and the return object going out. Okay. There's an exception, superassignment, which I'll touch on at the very end of this lecture. Okay. And that searches a higher scope, even the global environment, and modifies stuff there, but don't use it, okay? It's a dangerous operator. There's one context where you can use it, that's reference class objects, But outside of that, don't use super assignment. It can be tempting because you might be like, oh, this is going to do just what I want it to do, but I promise you it will not, okay? All right, so let's just kind of take a look at some scoping. Here's an example. So I define x, y, and z to be 1 in the global environment. X is 1, y is 1, z is 1, okay? Inside the global environment, we have we define the function f. Inside of f, we say y is 2, and then we create the function g, all right? Inside of g, we say z is 3, okay? And g is going to return the values of x plus y plus z, and f returns the value of g when we execute it, right? All right, so I'm going to call f in the global environment. What is it going to return? Okay, so think about this. I want you guys to think. I want everybody, don't just retype this in your computer and see what it does, but I want you to look at this and figure out what it's going to return. Is it going to return 3, 1 plus 1 plus 1? Is it going to return 6, 1 plus 2 plus 3? Is it going to return something else? Is it going to return an error? Okay, I want you guys to think what it's going to return. All right, and then after I run f, what will the values of x, y, and z be in the global environment? All right, you guys got your numbers in mind? Okay. So f returns 6, okay? So what it does is, it's when you run f, let's just start at the bottom. It says return g, okay? So when it says return g, it's going to search. It's going to say, well, what's g? Okay, well, g is defined inside of f. Okay, and it finds, oh, okay, g is inside of f. All right, so what does g return? G returns x plus y plus z. So it's going to say, okay, well, what is x? It searches here, there's no x. It goes higher, there's no x. It goes all the way up, x is 1 in the global environment. Then it says, okay, well, we're going to add y. What's y? Y, it searches here, there's no y. It searches here and goes, oh, y is 2. And so it does 1 plus 2. And it says, what's z? Z, it searches here, and z is 3, and it returns 1 plus 2 plus 3, and it returns, g returns 6, and f returns the value of g, so that returns 6. Okay. All right, what are the values of x, y, and z in the global environment after I've run f? 1, 1, and 1. Indeed, those values are unaffected. Okay. All right, let's talk about environments. There's a lot of stuff here, a lot of text. Okay, you can think of environment as it's the data structure that powers scoping, but you can think of it as a bag. Inside the bag, we have names, okay? We don't actually store the values themselves, okay? Inside the bag are names. Each name basically points to a location in memory that says the value that you want is inside this box in memory, okay? So here we can create an environment called new.environment, or just create stuff in the global environment, okay? And then we can say, all right, bind the name A to the value false, okay? And so we have the name A, and basically A points to an address, and we go, okay, well, it's right here. What's here? Here is the value false, okay? Okay, here's the name B. Where does B? Well, B points over here. What's inside here? Oh, the value 2.3, okay? And so on and so forth, and it has all of these things, okay? You work with environments kind of like lists, but it's a little different, okay? You use the double bracket operator, you can use the $ operator inside the thing, okay? Generally, you're working with a global environment, so you don't really have to worry too much about this, but you can do this, right? So you can say, well, what's the value of A? What's the value of C? E $C, double bracket A, okay? It's important to note that if you think of this as a bag of names, objects inside a bag do not have an order, right? There's no order, what's the first object in here? That doesn't make sense, okay? And so there's no, you can't index objects in an environment, okay? There's no first and second or third, right? So that's a big difference from a list. A list goes down, and you can see this is the first item in the list, here's the second, here's the third, here's the fourth. This is a bag, there's no order, okay? Meaning, the only way you can find things is by name, okay? All right, if there's no name, it doesn't even exist, right? Okay? And so this is what we have. You can ask for the kind of the structure of the environment. This looks a lot like a knit list, but again, there's no ordering here. It's just it might put these in alphabetical order for convenience, but that's that. Okay. So some differences here. There's no single square bracket for environments. With a list, you can null out. You can just kill a part of the list by nulling it. But here, if you put a null, it's going to store the name null or it's going to bind the name D to the null object, okay, which is different, right? So if you want to remove things from an environment, you use the rm function. ls lists off things in the environment. Okay, so in the global environment, you want to see what objects are available. You type in ls. If you need to get rid of something, you use rm. Okay, every environment has a parent environment. Okay. And the parent environment is used for lexical scoping, meaning if you ask R for a name, okay, like this, if this is your environment and you've got objects A, B, and C defined inside of here, and you say, okay, and then add A to D, it's going to say, well, I don't know what D is, so it searches the parent environment, okay, and it goes, here's D, okay, and then if it can't find it, it keeps climbing until it reaches the empty environment. The empty environment is the only environment that doesn't have a parent. All right. So kind of these are the special environments that we might be working with, right? Global environment, this is just kind of your regular old workspace. When you start up R, you're thrown into the global environment. Most of your stuff is created and saved in the global environment. The base environment is base package. Base environment contains all of the functions you take for granted, like plus and C and I don't know, all of these other things, right? So kind of like the basic functions of R, like things that create a list. That's all in the base environment. Okay. The empty environment is the ultimate ancestor of all environments. It's the base environment's parent is the empty environment, and the empty environment has no parent. Okay, and then and if you call environment, that's going to be your current environment. If you type in search, this will show all of the parent environments, okay, of the global environment. All right, so here it shows you're in your global environment. The parent of the global environment is package knitter. The parent of that is package stats. The parent of that is package graphics. It goes all the way up to package base, and then the only parent of package base is the empty environment, so it doesn't even bother listing that. If I come into R, let me restart my R session. Okay, I can just type in search. Okay, and it's slightly different from when I knit something. It starts with global environment, and its parent is tools RStudio, which contains functions pertinent to RStudio, like capital view, that function. Okay, so that's what it does. This is kind of how you can think of this, right? Here's your global environment. Here's a whole bunch of packages in between, and then it reaches the base environment, and the only thing that has a parent, base environment has the empty environment as a parent, and the empty environment has no parent. Okay. Anytime you call library, what library does is it inserts the new package that you just called into your search path. Okay. So here's the search path before. You call library, and it inserts a new thing here. So if I say library ggplot2, okay, it's going to take a moment here, and then if I ask for the search and compare it, it looks exactly the same as before, except package ggplot2 has been inserted in between the global environment and tools RStudio. Okay, so the parent of the global environment becomes the last package that you loaded. All right. Most of the time when we're dealing with environments, we're dealing with, it's because we call the function, okay? And when the function executes, it creates its own environment and stuff, okay? But every function has, different kinds of environments associated with it, okay? So the enclosing environment is where the function is created, okay? So every function only has one enclosing environment, and that's where the function is created, right? And then the other ones, you could have more than one of these things, okay? You have a binding environment. A binding is where the name is associated with the function, okay? So the name of the function exists somewhere. Most of the time, the binding environment and the enclosing environment are the same, okay? But there's some exceptions when you're dealing with packages and stuff. Most of the time, in your interactive use with R, the binding and enclosing environment are the same, okay? When the function is running, it creates its execution environment, okay, which we've talked about several times. And then whenever you call a function to run, technically, the place where the function was called from, that's known as the calling environment, okay? So if you call the environment, so a lot of times, enclosing, binding, and calling are all going to be the same. Like if you're working in the global environment, you create a function in the global environment, then that's the enclosing environment, right? And then when you name it, you're also in the global environment. So that name exists in the global environment. So the global environment's also the binding environment, okay? And then when you ask the function to run, you've called it from the global environment, and therefore the global environment's also the calling environment, okay? So a lot of times you don't even have to worry about these things, and the only thing that's different is that there's the execution environment, and I think we're kind of familiar, or getting familiar with this concept, right? But sometimes you define a function inside another function, okay? Or sometimes you define a function in the global environment, but then you call it from inside another function, okay? How does that work, okay? Or sometimes someone else wrote a function and it exists in a package, okay? And you are calling it from over here or something, all right? That's when there's distinctions between the binding, enclosing, and calling environments. All right, so how does this work, right? Okay, so let's talk about the binding and enclosing environment, okay? Wherever you make the function, that's the enclosing environment, okay? Where the name for that function exists, that's the binding environment. Most of the time, this is the same for you, okay? You're making stuff in the global environment. Where that name exists, if it's in the global environment, naming environment is the binding environment is where that name exists, right? Okay, so here in the global environment, I bind the name y to 1, and this is the picture, right? So y points to the value 1 in memory, okay? And then we created a function, okay? And because this function is created in the global environment, it's going to be in the global environment. And the name f, because I'm binding this function to the name f, f is also, the binding environment is also the global environment, okay? When you ask for the environment, this will give it the enclosing environment. That's kind of where it lives, right? All right, so where does this make a difference? This makes a difference in stuff like when you're dealing with packages and stuff, okay? So for example, right, so there's the variance function, and you can ask for what is the variance of 3, 4, and 5, right? Okay, and the variance of 3, 4, here, let's 3, 4, 5, 6. The variance of these 4 numbers is 1.667, and when you ask for the standard deviation of this, it gives you the square root of that, and you get 1.29, okay? Now, if you ask, how is standard deviation defined? It's actually defined as the square root of the variance, okay? So R runs this, right? So this is a bad idea, but I could create a new function called variance, right? And this is just going to return hello, okay? All right? So when I call variance, it returns hello, all right? And I can say, okay, well, what is the variance of 3, 4, 5, and 6? And it says error, unused arguments 3, 4, 5, and 6, because what it wants to do is return this value hello, right? However, if I call standard deviation of 3, 4, 5, and 6, this still works, okay? Even though standard deviation calls function variance, VAR, okay? And variance is defined as something else. So how do we keep track of all of this, right? Okay, well, standard deviation its environment is in this namespace stats, okay? So it's going to use this and start there to kind of search for the function variance, and it's not going to go down to my global environment and say, oh, let's use the variance function that's defined in the global environment, okay? And so the distinction between the enclosing and binding environments is important for functions inside of packages. And so to make sure that packages work regardless of what other packages are attached by the user, packages require an internal environment called the namespace in which the package functions are defined. Okay, so the functions are defined inside this package namespace, and then we get, so we have and so every function in a package will have the environment package and the package environment and the namespace environment. Okay, so the package environment is the external interface to the package. Okay, this is the environment which the R user uses to find a function in the attached package. Okay, and its parent is determined by the search path. So, right. So if we go back to this picture, depending on the order in which you load your packages, package of ggplot2 might have different parents, okay? And that's going to create problems if it depended on this thing, right? Okay. Whereas the namespace is going to be kind of where the things are defined, and that's not going to be dependent on this, right? There's something called the double colon operator, and this allows you to get a function straight out of a package, okay, regardless of the search path, right? So there might be another function named mean in a different package, and base double colon mean will use the mean function from package base, and mosaic double colon mean will use the mean function from package mosaic, regardless of the search path order, because otherwise R starts at your global environment and goes up the search path to find stuff, right? So trying to think how this works. Okay, all right, and then so that's the double colon notation. So if you see this double colon, it just means inside this package, use this function. Okay, and then the namespace is the internal interface to the package. The package environment controls how we find the function, whereas the namespace controls how the function will find its variables. So inside the namespace, that's where it says, you know what, use this name when you ask for var. When you ask for var, it's using the namespace environment. Okay, and that's how it finds functions that it might reference. All right, here we've talked about the execution environment, how when it's running, it just exists when the function is running, and then as soon as it's done, it disappears, right? So here, I define h inside the global environment, and I'm going to call h with the value 1, okay? All right, so let's just take a look at this, right? So here's h. H is defined in the global environment, and I call h with the value 1, okay? So function h is called with x equal to 1. So this creates an execution environment, and the execution environment binds the name x to the value 1. Okay, so this is just happens in the call. None of this code has run, right? So the next line says bind the value 2 to a. So the a is created inside the execution environment, and a is bound to the value 2. Okay, so this is created inside the execution environment. It's not in the global environment over here. Okay, and then we return the value x plus a. X plus a gets calculated. So we calculate the value 3, and 3, we return 3, and 3 gets bound, or y gets bound to the value that h returns. Okay, so y gets bound to the value 3, and this execution environment over here goes away. So that's what we have. All right. Is that okay? All right. So we're going to distinguish the execution environment and the enclosing environment and the calling environment. All right. So when you call a function, it creates an execution environment, and the execution environment has technically two parent environments. Okay. It's got the enclosing environment, which is where the function is created, and then it also has the calling environment, which is where the function was called. Right. If you create a function in the global environment and then you call the function in the global environment, then the calling and the execution environment are the same. It's not a big deal, right? But sometimes you might define a function in the global environment, so it's an enclosing environment is global, but then you call the function from inside another function, okay? So for example, like in the homework, I created isPrime in the global environment. And if you happened to call isPrime from inside your prime factor function, it wasn't necessary. But if you happened to do that, then that isPrime function's calling environment is the prime factor function, right? Because it was called inside another function, okay? The scoping rules in R say when a function is looking for a value that it doesn't exist in its environment, search the enclosing environment. So where the function is defined, search there, okay? But it also supports something called dynamic scoping, where you can look for values from the calling environment. So I got a couple examples of this. All right, so here, let's just take a look. X is 0, y is 10 in the global environment. Then inside the global environment, we define the function f. Inside f, we define x is 2, y is 100, and inside f, we define the function h. Inside h, we say x is 50, and return the value x plus y. The function f returns the value that it gets from executing function h. So if I run f in the global environment, what will f return? So think about this. All right. Confirm with your neighbor. All right, you guys got, okay, what do you guys think? Okay, so here it's going to return 150, right? So what it does is, let's kind of work backwards. So when we call f, the last line is h, so it says, all right, let's return the value of h. So we look at h says x is 50, return x plus y, right? And so when it looks for y, it doesn't find it inside of h, so it goes to its enclosing environment, which is f, finds 100, and does 100 plus 50, and it returns 150. Okay. Similar situation. All right, here I've got g. Inside g, x is 2 and y is 100, and we call h from inside of g. Over here with h, x is 3, and we return x plus y, okay? All right, so this part says, what will h return? Okay, in the global environment, x is 0, y is 10, and we're calling h. And so what will h return when we execute this? All right, confirm with your neighbor what you think h will return. H returns 13, right? Okay, so h, we call h, it returns x plus y. It searches for x, x is 3, it's inside your local environment, and then it searches for y, and it goes, h is enclosing environment, it's defined inside the global environment, so its enclosing environment is the global environment, so it finds 10, and it does 3 plus 10 is 13, and indeed, it returns 13. Okay, the next question, what will g return if we call g? So inside G, we say x is 2, y is 100, and then we call H. Okay. Turn to your neighbor, confirm. All right, well, let's just see. Who thinks it's 103? Who thinks it's 13? The answer is 13, okay? So when we call G, it returns 13. Why? Okay, let's look at this, okay? We call G, x is 2, y is 100, and then it calls H, okay? Is H inside of G? It's not. H is not defined inside of G, so what does it do? It searches the higher scope and it finds H in the global environment, okay? And then it's gonna execute H. When it executes H, x is 3, and y, it searches for y, and it's 10, okay? And it returns 13, okay? So what if you want it to return 103? What do you do, okay? So here, this is where we call dynamic scoping. Dynamic scoping is done with this variable function get, okay? So it's the exact same code. The only thing is I've added this one line where it tells H, when you search for y, get it from the parent frame, okay? Because by default, if it doesn't have y, it's going to search its enclosing environment, which is the global environment, right? Okay, so here, when we call H from the global environment, it's going to say x is 3. It's going to search for y. Because it's called from the global environment, it gets y is 10, and it's going to return 13. Okay? If you call G, inside G, x is 2, y is 100, and then we call H. All right? Again, here, H is called, it finds the H in the global environment, and inside H, x is 3, but then this function y says, don't go to your normal enclosing environment where y is 10, but use the values of y inside your calling environment. And in this case, y will take on the value 100. And so when you call G, you get 103. All right, is that all right? Okay. I'm going to talk about super assignment just because this I've mentioned it and we brought it up, okay? So when you do regular assignment, it always creates a variable in the current environment. So wherever you are, it's going to create a variable in this current environment, okay? Super assignment, which looks the same but with like kind of the double arrowhead, never creates a variable in the current environment, but instead modifies an existing variable found in the parent environment, okay? And if it doesn't find an existing variable in the parent environment, it keeps climbing the scoping ladder until it reaches the global environment, and then if it doesn't exist in the global environment, it will create a variable in the global environment, okay? And so this can be confusing and lead to all sorts of problems, okay? So you might think, after I talk about super assignment, you might think, oh, this is just what I need to accomplish my homework assignment or something, okay? No, all right? Don't use super assignment, okay? There's one context in which super assignment is useful, and it's reference classes, but we haven't talked about that. Don't use super assignment. I promise you, if you try using super assignment, it's only going to lead to making your debugging way harder and heartache and all sorts of broken promises and everything, okay? Let me just show you what happens, okay? So here, x, y, and z are 1 in the global environment. We define a function f. Inside the function f, we super assign 3 to y, okay? And so what this does is when we call f, okay, so right now nothing has happened. Okay, f hasn't even been executed. So x, y, and z are 1 in the global environment. But here, if I call f, it's going to take 3 and change the y in the global environment to 3. And then when it says return y, okay, there's actually no y to search for. There's no y doesn't exist inside f. Okay, it doesn't find it. So it climbs and it comes out to here and it finds that y has been changed to 3 and it's going to return 3. Okay, so f is 3, and then x, y, and z in the global environment are now 1, 3, and 1. Okay, so in this simple example, it seems like it works. Okay, I'm probably going to run out of time. Maybe we'll do this one. Okay, so here we have f, and we have inside of f we superassign, inside of f we define g, and inside of g we superassign this. Okay, and so what this is going to do is it looks for 2. It doesn't find. I mean, it climbs a higher scope and it changes the y to 2 in the global environment. Here, this superassignment of z to 3 goes into here and it looks for a z to modify. It doesn't find anything. So it climbs the higher scope up to the global environment and changes that to 3. And so, and it returns x plus y and z. And so there's no x here, it goes to the global. It searches for y, there's no y here, there's no y here, and it goes to the global. Okay? And it searches for z. And again, z is not defined inside of g, it's not defined inside of f, it goes to the global and pulls 3. And so, so it's going to return 6. 1 plus 2 plus 3, but then x, y, and z in the global environment are changed to 1, 2, and 3. Here we create 2, y is 2 inside of f, and then we superassign 4 to y in the global environment. Okay? Same thing as before, 3 gets superassigned to z, it searches for it here, it's not there. It goes to the global environment and finds z is 3 here, okay? And so when it returns x, y, and z, searches for x, no x here. Goes to higher scope, searches for x, no x here. Goes to the higher scope, finds x is 1. Then it asks for y. Searches here, there's no y here. Climbs the higher scope, and is there a y in the higher scope? Yes, and what's the value of y? 2, okay, so it takes 2. Searches for z. Is there a z here? No. Is there a z here? No. Is there a z here? Yes, it's 3, and so it's going to 1 plus 2 plus 3, and it gives back 6. What are the values of x, y, and z in the global environment? 1, 4. The y has been changed to 4 here. Z has been changed to 3 here, okay? All right, one more thing. Okay, you know what, I'm going to skip this, okay? You can review this in your own time. Again, don't do superassignment, all right? So you might have a situation where you're like, oh, I want to change this thing in the global environment, right? So like Chutes and Ladders, they say like, keep track of your moves, right? Keep a move log, okay? You might be like, oh, I just want to keep appending values to the move log in the global environment. So you might be tempted to use superassignment. Don't do it, all right? It's going to just lead to confusion and problems, right? So here's an example, right? So here I'm creating a function called add square root bad, okay? The bad version, where we're going to take a object foo, okay? And well, first of all, you shouldn't really be doing this, but this is, I mean, this in of itself is not wrong, okay? You take foo and then you're going to just combine it with x squared, okay? So if foo is 2, and then we do x squared, 5 squared is 25, and we combine those two, and we've basically added 25 to 2 here, okay? And this is the bad part, okay? The superassignment. We're going to say take foo, do x squared, and superassign it to foo, okay? So here foo is 2. I do add square root bad. Take foo, which is 2, 5, add 5 squared, and we get back 2 and 25. So we go, oh, this is just what I wanted. This seems like it's adding values to it. Okay, what's going to happen here? Okay, this time I have a new object called bar. It's 10, and I'm going to run the command add square root bar 6. Okay, 6 squared is 36. All right, so what will this return? What will be the value of bar in the global environment? what will be the value of foo in the global environment? So this is the function. So we're feeding it in with bar, which takes on the value 10, and x, which has the value of 6. So we've got 10, 6 squared is 36, and where does it go? Okay, so if I run this, bar takes on the value 10, bar is left untouched, and foo takes on the value 1036. Okay, I don't know if anybody was expecting this, right? But this is exactly what R is doing. It says, okay, well, you gave me 10, so here it is. 10 goes into here, x is 6, x squared is 36, and we're going to combine those two. We got 10 and we got 36, and you know what? Let's superassign this back to foo. So this foo comes here, but this foo is not here. It's not, so when I said bar is here, but it's not bar here. It goes to it superassigns to foo in the global environment, and so foo, which used to be 2 and 25, is now 10 and 36. These values 2 and 25 are gone and lost forever. Okay, and this is probably not what you were expecting it to do. Okay, and so superassignment bad. It's going to just be confusing, especially because what happens is when you run this, you have no idea which value is being modified. Okay, the modification happened right when I ran this function. Okay, but it's invisible. I have no idea which object I'm actually modifying. I think I'm modifying bar, but I'm not. I'm modifying foo. Okay, so if you wanted to do this, just use regular old normal assignment. Okay, and just have it return the thing. So here we're going to say take in argument baz, append x squared to it, and just return this thing, right? So here's foo. We do this, okay? Take foo, 5, and then we're going to save it back to foo. This makes it clear when I run this function which object I'm modifying. I'm modifying foo, so foo becomes 2 and 25. Here's bar. We take 10 and 5, okay? And we're going to store that back in bar. Bar is now 10 and 25, okay? There's no surprise here, and every time I take the results of a function and I modify another object, it's made explicit in my code. It's not just something that happens in the background here. I'm modifying an object here, but it's not being made clear to me. So when I'm going through and I'm trying to figure out where something went wrong, I have to have in my mind that, oh yeah, this is the function that modifies this other function in the global environment. It's not a good idea, not good practice. All right, we're going to wrap up here for today. Have a great weekend. Enjoy your Martin Luther King Jr. Day off, and we will see you guys on Wednesday.